There are different methods for process mining, but we can classify them according to 4 main classes on the basis of the purpose for using such methods. So for example, if we want to understand the process, then we would rely on automated process discovery methods, whose result would be, for example, a BPMN model. If we want to understand process conformance, then we would rely on conformance checking methods, whose result could be a checklist of the differences between our real business processes and certain rules. If we are interested in understanding process performance, then we would rely on performance mining methods, whose result can be provided in terms of dashboards or reports. And finally, if we are interested in understanding differences and root causes for variances and process deviations, then we can use variance and deviance mining methods, whose result can take the form of different models that we can visually compare, or on the basis of a statistical analysis, or it can take the form of patterns. Let's quickly look at each of these methods. The starting assumption of automated process discovery is that as organizations gain higher levels of BPM maturity, they tend to collect larger and larger collections of process models. The problem is clearly the cost of maintenance of such collections. Sooner or later, many of these models tend to become out of date. It's too hard, it's too costly, too error-prone to maintain them. Hence, they lose their value. The idea of process mining is actually to automatically discover these process models from event logs, provided the quality of these event logs is good enough. The idea is so to shorten the time that is taken for the discovery, to have results that are more accurate than those that you can typically get on the basis of traditional discovery methods, and so focus more on identifying weaknesses and issues that affect these business processes. So given an event log, process mining methods provide mechanisms to discover a process model, for example a BPMN model, but also other types of models like an organizational chart related to the resources that are assigned to a given process, or the social network that focuses on the handover of work between different resources participating in a given process. Moving on to conformance checking, this can take the form of 2 process models that can be compared. For example, a process model that represents a planned situation. For example, an order management process that is expected to last 3 days versus the process model that we actually discover. And then we can do delta analysis to identify the differences. Like, for example, identifying activities that are not meant to be executed and that lead to delays in the actual cycle time. Performance mining, on the other hand, allows us to obtain detailed performance measurements along different dimensions, whether that is cost, cycle time, or even quality, both on a static level as well as on a dynamic level. On a static level, we discover the model and enhance this model with performance measurements as we obtain this from the log. For example, we can identify average and maximum waiting time between 2 tasks, and we can focus on those waiting times that are the highest. Or we can do a dynamic analysis of performance by replaying the logs on top of the discovered process model in order to identify patterns of behavior such as bottlenecks or certain paths between tasks that are very frequently taken. Finally, methods for variance and deviance mining can take the form of different process models that are discovered on the basis of the different variants under analysis, or on the basis of normative and deviant process behavior. And then we can do a delta analysis in order to identify differences. For example, the differences between claims that are performed in Australia versus claims that are performed in New Zealand, like, for example, per state, per region, as well as on the basis of outcomes or durations. And then we can identify differences and back up such differences with statistical data. In fact, another type of outcome for variance and deviance mining is patterns or rules that describe, with a certain statistical confidence, the differences between variants. For example, a rule that tells us that in slow cases a given activity is repeated at least twice, while in fast cases it isn't. The input to methods for variance and deviance mining is 2 or more logs, each recording cases of a given process variant, called class. For example, 1 log for deviant cases and another one for normative cases.